All right, good afternoon, good evening, or good morning, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, and we have a demo, and I'm very excited about it. But before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on demand. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for either of our speakers, please don't wait. Don't hesitate. Just use the question and answer tab on your interface and submit your question, and we will try to get to as many as we can near the end of today's webinar. We also have a very interactive chat session on today's webinar on the interface, and we encourage you to use it to chat up our speakers and each other, and hopefully we can get a great dialogue going. And also, finally, at the end of today's webinar, we are going to be doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you'll be one of our 4 lucky winners. All right, with that, let's go ahead and kick off today's webinar, which is Best Practices for Modern DevOps, Architectures and Operations. Our speakers today are Sam Olukoton, and I'm sure I just got that wrong, but he's Senior Solutions Engineer at CircleCI, and Yaniv Bossum, who is Solutions Architect at AWS. Gentlemen, thank you both for joining me today. I really appreciate your being here. It's great to see you both.
Thank you so much, Arlene. Thanks DevOps.com for having us. So in today's webinar, we're going to talk a little bit about modern applications. My name is Yaniv Bossem, and I'm a partner solutions architect. I focus on DevOps in AWS, and I'm based out of Seattle, Washington. In today's agenda, we're going to start with modern applications with AWS. Then we'll move to modern DevOps features on CircleCI. And finally, Sam is going to show us a cool CircleCI product demo. We're going to leave some time at the end for our Q&A section. So at any point, if you have any questions, just feel free to post it, and we'll try to address them to the best of our abilities in the end. All right. I'll start things off with modernization. So, modernization is kind of a buzzword. It's being used for many different things, but I'll try and put this from the AWS perspective. So whatever the agency, organization, or institutions, customers, they want to become more agile, so they can become more, so they can innovate and respond to change much faster. The applications that organizations need to build today are vastly different than in the past. They need to scale quickly to potentially millions of users, have global availability, manage just enormous amounts of data, petabytes, if not exabytes of data, and respond to that data in milliseconds. These type of applications are what we call modern applications. They cover use cases such as web and mobile, backend IoT applications, AI/ML workloads, batch processing, platform as a service, microservices backends, and much more. So when customers modernize, the way that we see this, we can characterize this along 5 different vectors. They're architectural patterns, or modular services, developer agility with automated, abstracted, and standardized, data strategy. And we'll talk a little bit about data strategy later on. Distributed and fit for purpose and for use case. Operational model, and when we will also talk about that, as serverless and automated as possible. And management and governance, which means having programmatic guardrails for these architectures. Modernization, and specifically the adoption of serverless technologies, really changes how you work, and this applies to anyone who interacts with the application. So with serverless, for instance, you're adopting a new application architecture triggered by events and rethinking how you store state. You're also rethinking how you operate your applications. We long said that with Lambda and the rest of the serverless portfolio, traditional components of application operations like server management are entirely eliminated. Now, over the years, I know there was many analysts that were saying that eventually this is going to lead to something called no ops, However, no ops is not a reality today. What is true is that the role of application operators is just different. And today we look at these roles and a little bit of these changes that are happening in organizations to operate modern applications. But we'll start off with the architectures, and we'll start talking about modern application architectures. Now, looking about the difference of what we had in the past. So traditionally, applications were built with a monolithic style application, three-tiered web architectures that look something like this. You have your database layer, your application servers, and your web servers. Here's how we see modern application architecture. Now, yes, you're probably saying it does indeed look a lot like the three-tier web application, kind of the same thing, but there's some very important differences. The first major difference with this architecture is what you're seeing right now is not an entire system or an entire application. This is just a single microservice. This is not a monolith. So to really understand this, we have to kind of zoom out. Our customers, they run tens, hundreds, or even thousands of microservices, which basically improves their scalability and fault tolerance. Usually, microservices communicate via well-defined APIs. And many customers start the process of refactoring and modernization by wrapping their applications with these APIs. And we'll talk about that communication through APIs soon. The other key differences with this architecture is, and these are the ones that we're going to explore today, are actually three main ones. One is data. How and where you store the data is different in modern application. In this diagram, we can see multiple data stores. Each database is serving a purposely built task and has to solve a particular use case. We're not using one data store to solve all use cases. The other one is the application integration and the communication between the applications themselves. The way you communicate between both your application internally and also externally is different when you build modern applications. And lastly, the third layer that I'll talk about is compute. The logic where you write, that you write for your company or for your organization, wherever you work, that's the important piece of your business, and not managing undifferentiated factors of servers and capacity. And so we're trying to make sure that as much as we can, customers can build modern applications on top of technologies where they don't have to manage these underlying servers. So I named three, and I'll start with the compute as the first one. As you can see here in the diagram, if you look from the bottom, we look at this from the bottom up. You can start at the very bottom with EC2. And basically, when you build an AWS in EC2, you have the access to all the knobs you want to manage. And then you can go all the way up to serverless or to AWS Lambda or to Fargate if you want to run your containers on a serverless way. And that way you focus only on just writing the application code and not managing the servers. So the layers of abstraction available to you with AWS are super empowering because your teams have the choice to pick the layer of abstraction they're most comfortable with. And we'll also provide you with tools, services, and APIs necessary to help you build your application. Increasingly, we see customers opting to reduce their operational burden by opting for serverless services like Lambda for compute when they start building on AWS. So that's kind of an interesting trend where in the past we used to talk about try and lift and shift. A lot of customers start off with containers, with serverless, and with modern type of technologies. So we said there are three things I want to talk about: compute, and the other one, the second one was communication between the services. So broadly, we see two kind of categories of integration: synchronous or APIs-based integrations, and asynchronous or event-based. There's a few cases where APIs can be asynchronous, but generally this holds true. Modern applications use both types of integration. When choosing how to integrate, there aren't so much pros and cons as much as there are just things to consider when you're building your application. For example, are you communicating within a service or between services? In general, though not always, services are wrapped in an API, but use messaging and events internally to communicate between themselves. Event-driven communication, it's nearly infinitely scalable and also scales to zero, which enables a cost benefit, which is really substantial. So then comes the question of latency. APIs it's true, will have lower latency, but we don't think that sometimes when we make these architectures, we really have to see if we need that requirement for latency. because there are so many upsides for using event-driven when you want to scale and in terms of cost that we really have to consider if we want to stay with an API type of architecture. Finally, the agility piece. So think about this. I don't know which companies you work in, but if you've been in the IT for quite a while, you know that one team is developing one feature and another team is developing another feature. And these two teams, they want to go and develop fast and achieve speed. And when you work with events, it's much easy because there's no dependency between the teams. You just need to wait for some sort of event. You're taking an assumption that the event is there, and you're free to go and develop applications really fast. So that's kind of the difference between the synchronous or the API, where you have to wait for some sort of API documentation like Swagger, or events where you kind of assume that the event is there. So we talked about events, and I guess I was kind of teeing this up. So more and more customers are adopting SaaS in their organization. And so we're making it easier to incorporate basically SaaS data into an application through services like Amazon EventBridge. Amazon EventBridge enables customers to use data from third-party integrations in their applications. And we actively work with a lot of these SaaS integrations, but you can also build your own custom kind of event buses to ingest events from your systems. And what happens with EventBridge is that there's a producer that sends an event, and then the event bus has some rules in it. And when these rules match, it's being forwarded to a target, which is an AWS service. For example, you want to trigger a Lambda function that does something in your application. All right, so we said three things I'm going to focus on. One was compute, the other one was communication, and the third thing is the data. So let's look at data. For decades, because the only database choice was a kind of a relational database, no matter the shape or the function of the data in the application, the data was modeled as relational. And we would fit the use case, kind of for that model. So if we build something, we're trying to think about this relationally, and build around that. Now, of course, there are use cases where you need a relational database and a relational database model. But we're thinking about modern applications in a different direction. We're thinking that per use case, per function, you're going to need to build a different data model. And so it doesn't make any sense to have an SQL database for everything, where you can have other types of NoSQL databases or other things that you need for other applications that you're building. So if you want to build highly distributed and decoupled application, our job at AWS was to enable basically as many tools as possible and as building blocks for developers to use them. I won't go into each one of these different offering of database because we don't have time for that today. I'll just go over the categories. So the categories of the managed services that we provide for databases are with relational, of course. As I said, some use cases you still need that. Key value, we're our offering of DynamoDB. Document databases with DocumentDB, where you can use databases like MongoDB. We have our in-memory family with Elasticache. We have graph types database with Neptune. For time series database, you can use TimeStream. If you need ledger database, you can use QLDB. And we also released a wide column, or kind of the version for the managed Cassandra service, or as we call it right now, key spaces. All right, so we talked about the architecture and the three things. Let's move to operations. In a traditional application, there's one release pipeline shared between many teams. This process often, introduces bottlenecks. If, let's say, I'm a developer and I'm sitting here in this box and I'm developing a new feature, if that has to go through the same pipeline as all the other services, then you see where I'm going with this. You're not going to be able to release fast and to release a lot of features. For modern application, okay, we're thinking about a pipeline or a delivery pipeline per each developer stream. So there's that famous sentence that says, you build it, you run it. Developers should be accountable for basically running these pipelines and making these changes. So if I'm a developer sitting here, I want only this pipeline to be influenced by it and not the entire delivery pipeline of my organization. So, the problem is control. Now you're looking at this and you're telling yourself, so how do I maintain control between all my teams and all my in my company? Like, I don't want people to start putting in security problems into my into my systems. So that's kind of another approach, or something that we have for operations, which is called guardrails. It's one of the most important ways to ensure safety and security in a highly distributed environment. Let's look at the philosophical approaches for modern application. One on the left side here is free for all, fast developer time, no guardrails whatsoever, but it's a complete chaos and we don't have any governance on what's going on. The other one is, guardrails, fast time, low risk, and then we implement some programmatic, very important guardrails so that developers are falling under that umbrella. And central control, where everything has to go through some sort of security team and an audit. It's safe, but not recommended, because that way it will take you a lot of time to develop these applications. Of course, some applications have to go through a security audit, and these ones can be isolated to go through some central control. So guardrails usually are expressed as code. Guardrails are established and standardized through a central team. If we want to look at some real life or some real world guardrails, there are a few different areas we tend to see operations working in. The new role of application operations in modern serverless application is to set guardrails for those areas and to deploy updates and changes throughout the organization. We have monitoring and provisioning. For instance, if you have a certain rules that you want to add to your provisioning models with the CloudFormation template or with Terraform. We have services like AWS Control Tower, which is basically just an environment that has guardrails already implemented in it. And so everything you want to drop into AWS environment uses that control tower. The last topic here I'm going to talk about is our pillars of releasing modern applications. And we look at these pillars in terms of the CI/CD into three different pillars. I'll just talk about two of those, which is continuous integration and continuous deployment, and I'll talk about the goals of each one. Let's start with continuous integration. So continuous integration is that phase that we have in software development that we categorize as where we do source code and building. And let's have a look at the goals. So the goals for continuous integration is to automatically kick off a new build when new code is checked in. We want to be able to build and test code in a consistent and repeatable environment so that we can make small and often changes. We want to continuously have an artifact ready for deployment so that we can move it on to the next stage in the pipeline. And we also want to continuously be able to close the loop and get feedback if a build fails, whether it's through a notification to the developer, through an email, through Slack, or whatever that might be. Now let's have a look at continuous deployment. Continuous deployment is basically, throughout the software development lifecycle: source, build, test, and production. So the goal for continuous deployment is to automatically deploy new changes to staging environment for testing. We want to be able to deploy to production safely without impacting customers. So if we're doing things like A/B testing or canary deployment or using feature flags, these are kind of things that we categorize under the umbrella of continuous deployment. And lastly, the last goal is to deliver for customers faster, increase deployment frequency, and reduce change lead time and change failure rate. So with that, I know I said a lot, and I'm happy to take any questions in the end if you want to post them to your Q&A chat. But with releasing modern applications and to properly have a CI/CD process in place, one of the things that we suggest is to use proper tools for that right job. And I just want to transfer it over to Sam to talk to us about CircleCI and kind of their offering and what they can help you as developers. Take it away, Sam.
Thank you, Yaniv. May I get a thumbs up if you can hear me right now? Awesome. Sorry, everyone, I had to turn off my webcam. I'm having network issues on this end. But as Yaniv said, I'm with CircleCI. And here we like to say our mission is to make it as easy as possible to go from idea to delivery. So what are we really talking about when we say easy as possible to go from idea to delivery? What we're really talking about is that we want to empower engineering teams to move from feature and value creation to customer delight with as little friction as possible. As a company, we were founded in 2011. We now have almost 500 employees spread across 5 continents. We are currently the world's largest shared CI/CD platform, and we're running over 3 million builds per day on our platform. As a framework agnostic platform, it means we're able to support all major platforms and operating systems you might have today or on projects you might bring in the future. If we take a step back and try to see where CircleCI fits in the tool chain, you can think of your source control and all the code you write as the creation side of things. And you can think of your Docker, your Heroku, and all the endpoints where you push your application as the logistics sides of things. With that viewpoint in mind, you can then see CircleCI as the orchestration engine in the middle that helps automate your build, your test, and your delivery. Some of the things that make CircleCI different as a platform is that we put the developer experience first. In addition to that, the fact that we are toolchain agnostic and that the platform adopts extensibility as a philosophy makes it easy to bring any toolchain that your team might be working on today or in the future into CircleCI's platform. In addition to that, achieving scale and high performance on CircleCI is easy and intuitive. And our industry-leading security certifications, the best of breed technology, as well as the multiple level premium support options that we have, make CircleCI a favorite option for enterprises that are looking for security, support, and control all in one platform. Next, I'm going to be talking about some of the features that empower development teams to move fast and scale quickly on CircleCI. First of all, CircleCI offers several hosting options to meet your need. We have cloud offering that's fully managed and is the most flexible of our hosting options. We also have the server offering that gives you more customization and more control over your instances. And thirdly, we have the runner option, which you can consider as a hybrid between cloud and server, as it allows you to run your own build agents while still using our fully managed UI and insights on the cloud platform. Another thing that we implement in CircleCI that you might have seen in Yaniv's segment is the idea of configuration and infrastructure as code. Implementing your CI/CD pipelines as code allows you to treat your pipeline like the rest of your source code. This means that you can audit changes, you can easily track them, and also easily understand what's happening in your pipelines. Docker layer caching is one of those features that really does speed up build times and performance on CircleCI. Containerization is one of those ideas that is a leading best practice in building modern applications. And if you build a lot of Docker images within your pipelines, the Docker layer caching on CircleCI allows us to cache any layers that may have not changed from one build to another. This means that next time you run a build of a Docker image, if you're reusing some of those images, your build times run faster. Concurrency and parallelism are also other features that you can take advantage of to make your builds run faster. Concurrency, you can think of it as how many different jobs or how many projects can be running builds within your organization at the same time without creating a bottleneck. Parallelism, on the other hand, is how many jobs you can run within a single pipeline without creating a bottleneck. Both of these metrics on CircleCI scale dynamically and without any additional infrastructure needs for you or your team. These are one of those features that makes teams' experience on CircleCI a lot easier and more intuitive. Parallelizing tests is another one of those features that allows you to run things quicker simply by splitting your tests across multiple nodes on CircleCI. With this feature, you can split your workloads among multiple machines, and this essentially allows you to run your test in a fraction of the time as it would take to run it on one container. The customizable compute, or as we like to call them on CircleCI, resource classes, is another feature that allows you and your team to fine-tune how much compute you're using on our platform. As Yaniv pointed out in his segment, the whole idea of pay for compute or only pay for what you use is one of those underlying philosophies or one of those benefits you get when you take a more modern approach to building your application. The fact that CircleCI offers you multiple options for your resource classes gives you the option to then pick the most appropriately sized resources for your particular project. On the next few slides, we're going to be showing the different resource classes we have for the various execution environments we support. On CircleCI, we support Docker, and you can see the different resource classes that we have under that execution environment. We also support Linux, as well as Mac OS. And in addition to that, we support Windows. ARM64 is currently in preview, and we also have an Android image coming out, also in preview right now, that supports nested virtualization as well as built-in emulators. Finally, I would like to talk about Orbs. Orbs on CircleCI, you can think of them simply as a reusable, shareable package of CircleCI configuration. So Orbs you can think of Orbs as chunk of configuration that you can check into CircleCI's central registry, and then you can reference them from multiple configuration files across any project. This helps you eliminate duplicate work in implementing configuration, and it also helps to codify and share config across multiple teams or projects that may have similar processes. On this slide, I am showing a few examples of the Orbs that we have already implemented. This is by no means all of the Orbs we have, but if you have any third-party tools that you want to implement or integrate with your CI/CD pipeline, I typically recommend checking out our Orbs ecosystem. It's constantly growing, and we're continuously adding more Orbs to the system. And now we're going to be playing a short product demo for you. Greetings, and thank you for joining me. Over the next few minutes, I would like to show you a few of the features of CircleCI. If this is your first time logging in or signing up to CircleCI, your journey will begin here at circleci.com. Over to the right of the screen, you will see the login or sign up buttons. Clicking on either one of them will take you to a page where you can log in with either your GitHub or your Bitbucket credentials. This is one of the advantages of how closely CircleCI integrates with your VCS. By integrating closely with the VCS, you don't need to maintain a separate access control list to use CircleCI. CircleCI automatically inherits the permissions and the authorizations that have been provisioned for the developers within GitHub or Bitbucket. Once you log in, you'll be landed on this page where you get access to all the projects that you have permissions for within your VCS. This is another example. This is another one of the advantages of having that close integration between CircleCI's cloud platform and your Bitbucket or GitHub accounts. By virtue of that integration, we're able to make the onboarding process easy and seamless for you. Take, for instance, if I wanted to onboard this online groceries app project. All it would take would be clicking on Set Up Project. And since this is the first time bringing this project onto CircleCI, I could choose any of our templates here to just provide a simple config file in order to get this project building on CircleCI. I could say node, for example. I would say commit and run. And in a matter of a few seconds, you will see this project building on CircleCI. And voila. So that is just to show you how intuitive and easy it is to get your new projects up and running on CircleCI. Moving over now to a project which I've already been building. This is what I want to spend most of the time of this demo talking about. First, before we dive in, I just want to do a brief touch on vocabulary. During the demo, when I talk about a pipeline, I am referring to anything that runs as a result of a single commit. In this particular case, this pipeline running on this master branch as a result of this commit includes one workflow. The workflow itself is merely a collection of the jobs, which you can think of as the individual tasks you want to run within your workflow. So moving over to see what this workflow is doing. At a high level, I am running my test and linked jobs in parallel as soon as I push a commit. If those two jobs succeed, I want to build my application. And if my app builds successfully, I want to hold the application for an approval step. In this case, I want to come in here, click on Approve to deploy. And once that registers within the system, then my deploy step will kick off. So again, to talk about the features that this is taking advantage of, I'm taking advantage of my parallelism here, which allows you to run as many jobs as you want in parallel. I'm also taking advantage of an approval step here, which allows you to get the process within your pipeline in order to pen for a manual interception. Now, to talk about the configuration or how you set this up on CircleCI. On CircleCI, all configuration happens in a YAML file. So this means two things. First, you get to manage your config as code. And secondly, you don't have to learn a new programming language in order to start using CircleCI. There are three sections of this config file that I would like to talk about. There are the Orbs, the workflows, and the jobs. Starting with the jobs, you can think of the jobs as the collection of commands you need to accomplish a specific task. Take my test job, for instance. What it takes to define a job on CircleCI is first an executor. An executor on CircleCI, you can think of it as the execution environment within which that particular job will run. In this particular case, I am picking Docker. However, on CircleCI, we support Windows, macOS, Linux, and Docker. If you do choose to use the Docker environment, CircleCI also provides a suite of convenience images that are optimized for performance and for individual tool chains. In addition, I'd like to point your attention to line 44 here, where I am specifying what we call a resource class. The idea of a resource class on CircleCI you can think of as the specs or the computing power of the machine that is running your job. In this particular case, I am using extra large, but CircleCI offers you options from small all the way to 2 extra large plus. Another feature I'd like to point out on line 45 here is parallelism. This allows you to split your job across multiple nodes. On other platforms, being able to implement or achieve this level of parallelism would require you to manually configure additional nodes or spin up machines that would run the job for you. On CircleCI, all of that is simply reduced to specifying the number within the config file. One last feature I'd like to point out here is the ability to cache dependencies on CircleCI. By caching your yarn.log file or package.json, for example, you can make sure that if your config file, if your dependencies don't change from build to build, CircleCI does not need to reinstall all of those dependencies. By reusing the same dependencies from a previous build, we allow you to save time and speed up your overall builds. So those are jobs at a high level. Next, I'd like to talk about the workflows. The workflows, as I point out here, is a collection of jobs and just how you orchestrate them to run. In this particular workflow, I have defined a build, test, deploy, which runs my lint and test in parallel. It runs my build if my lint and test succeed. Then it holds the job for approval. And after that is approved, then it kicks off the deploy stage. To go back to the UI and give you a visualization of what that workflow was doing once again. Here's my test and lint running in parallel. The build waits for test and lint because in the config file, I specified them as requirements for the build job. And then there's the approval job that then kicks off the deploy. All of that is just to show how intuitive it is to set up a workflow and to orchestrate them on CircleCI. Finally, I want to talk about the Orbs. Orbs, you can think of them as reusable modules of config logic. I come from a JavaScript background, and I like to describe these as node modules, for instance. Imagine you had a node module that was checked into the NPM registry. You could import that node module into your JavaScript file, and then invoke all the commands that are defined within that module, instead of having to define them within your own code. A similar effect is what we're doing here with the idea of orbs on CircleCI. These orbs contain logic or pieces of config that have been defined in our orb registry, and by importing them into this configuration file, I can take advantage of those commands that are defined in these orbs simply by invoking them in step on line 55, for instance. I do the same thing on line 56, on line 65, and on line 66. All of this syntax does is it invokes these commands that are not defined in this config file, but are written within these orbs that I am invoking here. If you're interested in exploring the variety of orbs that we have available on CircleCI, I typically recommend to new users to go to our developer hub. You can get there via circleci.com/developer, click on orbs. And here, if you have any third-party integration, any tool you're trying to interface with via your CI/CD pipeline, I recommend you usually come in here and you search for it. If you're going to be deploying to AWS, for instance, it always helps to pull in one of these orbs instead of rewriting all the logic yourself. If you'd like to get notifications to Slack, for instance, we already have an orb written for that. So those are orbs. They allow you to templatize chunks of configuration and share them across your teams or other projects. Going back to the UI, we've talked about what it takes to set up a successful build on CircleCI. Next, I'd like to talk to you about some of the features that CircleCI puts in place to enable you to quickly recover from a failing build. First of all, we give you a clear visual indication of what has failed. Unlike some other platforms where you'd have to dig through logs to figure out what has gone wrong, on CircleCI, you can click on that particular job and get more details on each individual step that has run as part of that job. In this particular example, I can scroll down and find the step that failed. I can expand that output, and I can see that it's a failing test. If this was a flaky test, for instance, projects tend to have those once in a while, you might want to rerun this job to get this pipeline to pass. CircleCI provides you with easy convenience features that allow you to either rerun the entire workflow from the beginning. You could choose to rerun it just from this job that has failed, or you can choose to rerun just this particular job with SSH enabled. In this case, CircleCI will rerun that job with all the exact same parameters of the initial run. The only thing different in this particular instance is that once the environment has been spun up, we add this additional box for you with a command you can copy and paste into your terminal to SSH directly into the box that is running that build. It's a very nifty feature that a lot of developers take advantage of to quickly debug their builds. Finally, I would like to talk about our Insights dashboard. The Insights dashboard is where you can go to get summary metrics around different projects in your pipeline or even specific workflows. You can get things such as their total credits, how long they've been taken to run, number of runs, as well as success rate. If you'd like to dive deep into any one of these individual workflows, you can click on that and you'll get more details with more graphs for those particular workflows. Furthermore, you can filter each one out depending on branch. In this particular view, you get access to the recent workflows run, as well as success and failures. You get a representation of success rate. You get a graph of the workflow duration, as well as workflow credit usage. If this information is appealing to you, but you would like to see it in a different format, or if you have an internal dashboarding tool that you'd like to present this information within, for instance, you can take advantage of our API, which has an endpoint, a series of endpoints actually, that feed all the insights metadata directly to your internal login platforms. So those were all the features I wanted to talk about. It is by no means an exhaustive list of the features. If you would like to play with any one of them, feel free to go to our website. We do offer free trials. If you would like a more extensive, fully enabled performance trial, you can contact us via the link on our website, and one of our account executives will reach out to you. Thank you again for joining me.
All right. Thank you very much, Sam. I think at this point of time, we can move to our Q&A section.
Yeah, so we've gotten some great questions in so far, but there's plenty of time for question and answer, guys. If you have a question for Sam or for Yaniv, go ahead and use that question and answer tab and go ahead and submit it. You can also put it in the chat area and we'll be more than happy to move it over for you. Let's see, what do we have for you guys tonight? Okay, first of all, let's see, Sarah is asking, and I believe this one is for you, Sam. I wonder if you have some references you could share in Korea as well.
All right, if you're trying to contact our team in Korea, you can go through our website. We have a contact us link there. And if you just put in your information, we'll route it to the appropriate team and they will reach out to you.
All right, great. All right, next question here. Let's see. Here's another one for you, Sam. Can I schedule multiple workflows on CircleCI?
Oh, yes, you can. So CircleCI does not limit the number of workflows you can run. You can schedule as many as your team needs to run. Our unlimited parallelism and unlimited concurrency allows you to achieve that.
All right, great. All right, guys, like I said before, we have lots of time for question and answer periods. So go ahead and get any questions that you have in, and we will, I'm sure we'll have time to get to your question. Here's one for you, Yaniv. Do I have to use CloudFormation to provision AWS resources?
Right. Yeah, that's I think that's a question that I can unpack looking only at CloudFormation or also other tools. I would say, first of all, let me answer the question, and the answer is no. You can use any tool that you're comfortable with to provision resources and keep using these tools. In general, you know, AWS tries to support the open source community and also the partner tools, and work with various different partners to support their tools and have better integrations and better experience for you to work with AWS. So even if we take that entire software development lifecycle from start to finish, you can see that you can use VS Code or IntelliJ for authoring your applications. For sourcing and artifacting, you can use services from GitHub or GitLab, whatever is comfortable for you to use. For building and testing, you can use tools like CircleCI that we saw here today, which is awesome and really simple to use. Let's say you run containers and you want to deliver them, you can deliver them with Spinnaker. Or if you're doing GitOps, you can use Flux from Weaveworks. If you want to monitor your applications that are running on AWS, where you don't have to use CloudWatch, you can use Prometheus and Grafana, or you can use other tools like Datadog if you're using them for monitoring your applications. And then finally, for provisioning architectures or for modeling, you don't have to use CloudFormation. You can use Terraform. If you're more comfortable with CDK, you can use the AWS CDK, or you can use Pulumi CDK, and you can use tools like Docker Compose. So all of these for modeling, and I guess throughout the entire kind of chain of your software development lifecycle, you can use various different tools, and you don't have to use the AWS tooling for that.
All right, great. Here is another question for you. I think maybe, Sam, this one is for you, but I'm not entirely sure. Any thoughts on compliance and regulations being pushed through the pipeline?
That's an interesting question. Typically, when the compliance and regulations question comes up, it's usually around being able to meet compliance or regulatory requirements from the pipeline. So for instance, if you're going through an audit process, you want to be able to easily audit the pipeline to figure out which engineers pushed which jobs and what applications were deployed and when those versions were deployed. So from that perspective, it is always important to have a CI/CD tool that makes it easy to get all those reports or to get all that information when the audit period does come around. At CircleCI, we're proud to say that we do meet a lot of industry compliance and regulatory, wow, that's quite a word, regulatory requirements. And so we have FedRAMP, for instance, and we have SOC 2 Type 1 and Type 2, I believe. All in all, we're one of the most certified CI/CD platforms in the industry. So from that perspective, I'd say you wouldn't have any problems meeting compliance or regulations if you're using CircleCI.
Excellent. All right. All right, let's see. We have one more question here. So there's plenty of time, guys. If you have a question for Sam or for Yaniv, go ahead and use that question and answer tab, and we'll get right to it. Sam, here's another one for you. How do you count active users on CircleCI?
Active users on CircleCI are only going to be those who push a commit that trigger a build on CircleCI. So essentially, only the engineers within your organization who have right access to a repo. Those are the ones who are going to be counted as the active users on the platform.
All right. Okay. All right, here's another one for you. How do I chain workflows, i.e. commit in repo A, builds and triggers a build on repo B when it completes? Oh, I see. A commit in repo A builds and triggers a build on repo B when it completes. I get it. Okay. I think that one is for you.
That's
Sam.
a great question. Oh, yes. That's something I would see a lot of teams do, actually. And there are two ways to accomplish that. One of them is you can use our API to trigger the other workflow at the end of workflow A. So what that would look like would be the last job that runs in workflow A. Once that succeeds, the latter workflow B. A second way to run it, which is a new feature that we're actually recently releasing, it's in preview right now, is called a set up workflows feature. And what that does is it allows you to have a segment within your config or within your build pipeline where you can think of it as a sort of a pipeline setup. So within that stage, you can run additional logic, and based on certain conditions that are met, you then decide which workflows are going to run. So for this particular use case, what that would look like would be, based on the setup workflows logic, you can decide this particular build needs to run workflow A and workflow B in series. And then based on that config, it would achieve the similar pattern as triggering workflow B from the API. That was a mouthful, a lot of words. It's probably going to be easier if you get on a trial with CI, and then we just work that out.
All right, great. Well, that is all the questions that we have right now. I'm going to leave the question and answer tab open to see if we get any last minute questions in. As I said before, we still have lots of time, so we should be able to get to your question if you get to it. So go ahead and get it on in. And while we are waiting to see if we get any more questions in, I just want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. Following the webinar, we will be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the DevOps.com website, so you can always go find it there. Just go to DevOps.com/webinars, look in the on-demand section, and it should be right there waiting for you. All right, doesn't look like we are getting any more questions in, so I am going to move on to the drawing for the 4 $25 Amazon gift cards. So let's go ahead and do that real quick. All right, our first winner today is Luis O. Congratulations, Luis. Our second winner today is Pete T. Congratulations, Pete. Our
Yay.
third winner today, yay! Third winner today is, see, this is my favorite part of the webinar, when the speakers are all about their Amazon gift cards, like, yeah, winners! So, okay, our third winner today is Stephen L. Congratulations, Stephen. And our fourth and final winner today is Jonathan S. Congratulations, Jonathan. We'll be following up with all four of you via email to get your Amazon gift card over to you. So please check your inbox. If you don't see it over there, please check your spam folder. All right, so looks like that's it for question and answer period. We didn't get any more in, so I do want to thank everybody who did submit questions. If you have any like last second questions, you can go ahead and get it on in. If we don't catch it in time for the webinar before it shuts down, then please know that the folks over at CircleCI will be getting a copy of all the questions that came in, and I'm sure if we didn't get your question during the webinar, they'll be more than happy to follow up with you offline to get your question answered. All right, Yaniv and Sam, thank you both for such a great presentation and demo. Gotta love the demos. It was a great presentation. Thank you so much, guys. Appreciate your time and your expertise as always.
Thanks for having us.
All right. And I do want to thank the audience also for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.